Now instead of looking at our plan view, we're going to be focusing on our profile view. And so we're going to again start with our plan or profile start seed file, and we're going to duplicate that file and then rename it to profile sheet definitions.dgnlib, and then we want to go ahead and open that file. In your navigation workflow bar, make sure to switch to the drawing production, place name boundary, and then choose the civil profile mode, drawing seed again, set to none, and we are creating a singular profile sheet. So we'll set our detail scale as we did before to 1 to 500. A1 profile. Make sure that your method is set now to station limits because we're going to be working in the profile. We won't be getting our border locations from the plan view this time. Our start station is going to be down here. We're going to pick in our profile view, set that to 0, and then our stop location again will be 350. So our length is 350. I'm going to set the vertical exaggeration here to 10. You can set it to 5 or 2, whatever you want. 10 seems to be a pretty reasonable number. And then we have the available profile height. I'm going to change this to 20 with the understanding that the number that I put in here is multiplied times the vertical exaggeration. So if I have a profile border height on my border cell of 200 meters, then at a 10 exaggeration, I need a profile height here of 20, as 20 times 10 is 200, and will fill up that entire rectangle in my cell for a profile only sheet. The top clearance gives us a buffer. Essentially, it takes away from the 200. In our case, 5 feet down is the maximum. And what this does is allows for text at the top of the profile labeling to not go outside of the grid. Same scenario on the bottom. Typically, you don't necessarily have annotations going down the bottom, so I've let that set to 0. The elevation datum spacing is typically an interval of your horizontal grid lines in your profile, representing elevations. And then your station datum spacing value goes along with how you want to handle profile shifts. In other words, if it is going to vertically shift your profile, almost like a stair-step type look, what is the minimum width you want to use to offset? And so that's set up as appropriate. Make sure your toggles are all on for this particular example, and then choose in your profile view to place that boundary, and then accept it, and that will pop up our Create Drawing dialog. Make sure that your mode is Profile. Your name should carry over. Set your discipline to Civil. And your purpose, if you want to type in Profile View here, you can. The seed model, again, is selected from your Seed 2D metric drawing. And we'll set our ratio here. And that is for your paper to drawing. And this does support the profile grid annotation, and this was pre-prepared in the workspace for the annotations to draw the horizontal vertical grid lines as well as the strip grades along the bottom and the stations and ticks. Then we have our sheet seed model. We'll select, and we will set our detail scale again to 1 to 500. And you can see all of the settings, and then we will select OK. So this is our singular profile. Navigate back to Home, Drawing, and then we're going to place our border again. And so this border is our A1 profile border. And then we'll go back to, again, our reference attachment tools. Make this dialog a little smaller. And we're going to move our reference, snapping to our grid location. Move our handle. and then move our corners, just like we did in our other exercises. And then we can make sure to remember and turn off our construction class and save our settings. It's always a good practice to review the properties to make sure that your name is the way you want it to be set up for the user. So that all looks good for a single profile sheet. And just to close this out, we'll go back to our drawing model and we will fit view, save settings, back to our default model, open up again our profile view and save those settings. And that completes setting up the profile sheet definitions DGN library.